Hello again. In this section, we're going to look at solving polynomial inequalities based on the x values. That's what it means. So first, let's look at what do we mean by polynomial inequalities. I wrote the polynomial function for you, which is right here, f of x. And this is a polynomial function, and it's given by what you're used to, x cubed minus 2x squared minus 5x plus 6. That's a typical cubic function, and that's called a polynomial function. The polynomial inequality, you don't see any f of x anywhere because this is f of x. That is f of x. So what we are saying is that we want to solve this polynomial inequality for values of x. Another way of writing this is as if we say, can we come up with all values of x where f of x is greater than 0? That's what this means. Okay, these two, they are synonymous, exactly the same. All right, process of solving polynomial inequalities. Number one, you have to find all the x-intercepts, all the roots, or zeros, whatever you want to call them. And we can use whatever method we like to. We can use long divisions, factor theorem. If it's a quadratic, you can do factoring. If whatever method that you like, but for the most part, you're going to rely on factor theorem, and then to get the first factor and possibly do a long division to get the other factors, and then go ahead. And you can possibly use the rational root theorem as well. So as I said, whatever method you like. After that, we use those x-intercepts once we have them, and we draw a sketch of that graph. It doesn't have to be exact in terms of the peaks and valleys of it, but it does need to be exact in terms of x-intercepts, okay? Because that's where we can see where the graph, the inequality is true or not, depending on what kind of an inequality we have. And that's where what we say, we have to use the characteristics of the graph or the function so that we can sketch it semi-accurately in terms of the region, in terms of the end behavior. And then using that, then we can come up and find the x intervals in which the inequality statement is true. Okay, and then at the end we can just write up the interval, and that would be it. So look at this example, and you can use the rational root theorem and solve this. And this basically, what it means is that you have to basically look at all factors of 6, or if you want to use a rational root theorem, be aware that the coefficient in front is 1. So rational root theorem said all the factors of 6 and all the factors of 1, you divide them and then list them, but it turns out to be all factors of 6 anyways. So what are they? Well, we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Great. Once you have that, then you're going to use factor theorem. So go through each one, and to save you time, this is what you will do, is that you go through each one of these, and it turns out that when you do that, you're going to have a few factors. For example, we check f of 1 will give you one of the zeros. That means x minus 1 is a factor. Okay? That's what it means. But what you need is that this 1, that's one of the zeros. The next one is f of minus 2. That would be 0. So that means, again, you have another 0. So 1 0 in here, another x-intercept there, okay? And then when you continue doing that, you notice that f of 3 is also 0, and then you get the third 0, and it's a cubic, the 3 zeros, you're done. Now, I've gone through this already, but that's what you got to do. There's no easy way out of this. You have to go through either do the factor theorem, and once you get the first one, you can use a long division. You get the quotient, which is going to be quadratic. Then you can use a quadratic formula, whatever method you like. But you will end up getting these 3 zeros. And once you have these 3 zeros, then you were going to sketch the graph of the function based on the characteristics of the function that you see on the equation. Okay, so that's what we're gonna do. Okay, so based on these, we have these zeros. So I have minus -2 on this side, we have 1 in here, and we have 3. And I basically chose the vertical, the y values in terms of partition. Each of these squares 2. But then the x-axis, the partition is different. So that's my x, that's y, and that's a sketch of it. And the reason the end behavior is from between the quadrant 1 and quadrant 3 is that the leading coefficient x cubed is positive. Okay, we do know that it goes through 6 because 6, the constant term of a polynomial function, that is your y-intercept. So we know that for sure. Okay, so we can actually accurately do the graph on this one. So here it is, that's the graph. Now we're going to go ahead and answer the question, solve the polynomial. And the polynomial says we want all values of the polynomial functions for values of x that are greater than 0. So I mean, we want the function be greater than 0. That means we want the part of the graph that is above the x-axis. The y value you want above the x-axis. So that part of the graph is above the x-axis, and this part of the graph is above the x-axis. And based on that, what are the interval values for x? Well, just look at the graph between -2 or -2 and 1, that's above the x-axis, and everything past 3 or above 3, more than 3, is above the x-axis. So the way we write this, we write it same as saying as an interval. We put the x in the middle. So because the inequality is strictly greater than, so that's greater than. Okay, so let's make a note. F of x, we want to find all values of x that is greater than. All right, greater than means that it's not equal to. That means these values actually are not part of the solution. Okay, so the way we write the inequality, we say exactly that. So x has to be greater than -2, less than 1, comma, and then we're going to include that piece, which is, that piece is x has to be greater than 3. And that is it. That is basically it in terms of the graph of that, and in terms of the solution. Okay, so now let's put them on the number line, if that's what you want to do. So on a number line, so let's do, this is 1, this is 3. If that is 0, that should be -2. So the way we do the interval, we write it like this. Between 0 and 1, all of those values are part of the solution, and then from 3 on, or greater than value. And that would be the solution to the polynomial function f of x greater than 0, which where f of x is x cubed minus 2x squared minus 5x plus 6 greater than 0. Okay, that's how you will do it.